So, welcome to our second session. Hello, everyone. Good evening, good morning, good afternoon, based on your time zone. I'm Fayrouz, and it's my pleasure to be the host and the, the moderator for this second session to be of ICICT 2022. Dear authors and the invited guests, it's my pleasure again to welcome you on behalf of the Global Knowledge Research Foundation. And thank you for being part of the 7th International Congress on Information and Communication Technology through Zoom. Further, as you are aware, we have been facing new situations while we are overcoming the pandemic, but new things come up. So hence the conference shifted to be on the hybrid mode. We are very thankful for everyone who present here and going along the digital version of the conference due to the unpredictable circumstances post-COVID-19. Without you, this conference would never be that productive. Also, wish you and your families a protected time. We hope that you will enjoy the 2 days conference. It would be hopefully an eligible and interactive digital session as much as we could. Also, it's a special note of thanks for our presentations that you will have 10 to 12 minutes of presentation. 3 minutes would be left for the questions and answers for the participants. If you have any question to the presenter, you can send it to the chat. I will read it on your behalf. Otherwise, we will have the chair questions and notes. I will request all you to get muted unless you are presenting. This will make sure that we don't have any noise on the background. And thank you again for being here. First of all, it's my pleasure to introduce our chair, who will for sure add a great value to our knowledge and the positive feedback that we will get. The constructive information will be also an added value to all of us. So Professor Bal is a director of the Center of Communication and Technology Research Group. His research is in the area of microwave wireless communication, encompassing 5G mobile phones to satellite technology. Professor Bal graduated with a bachelor's degree in engineering with honor and communication technology and MPhil from Leeds University in the UK. He obtained his PhD in the University of North London, also in the UK, and he was worked as an academic in the Open University and Leeds University. Prior to this, he was a research and development electronic engineer in the Future Products Department. So he has great experience that will again reflect to you. So welcome, Professor, and thank you for being the chair of this session. We will start with the first presentation, which is really interesting. For me personally, as I really like to know more about DevOps. So we'll start with DevOps best practices in highly regulatory industry. It will be presented by Ms. Rath. It's over to you, Ms. Rath. You can share your screen. I will stop sharing now. You can share your screen and go ahead. All the best. Thank you.
Thank you very much, Feroz. My paper is on DevOps best practices in highly regulated environment. The reason I've chosen this is because I was one of the team who've written the IEEE 2675 DevOps standard. I'm particularly interested in the highly regulated environment because I think many of the areas where DevOps is applied is often areas that are loosely organized, perhaps use agile techniques. And DevOps applies equally to areas that are highly regulated. And I want to show you why it's important not just to look at industry reports, but to look at standards and apply them directly. So if I move on. So the first question that I think we all ask when we think about DevOps is, what is it? And you'll find many definitions out there, and that's part of the problem. Some of these focus on customer value. Some focus on continuous improvement. In fact, many people tell me that DevOps is continuous integration, continuous improvement, but it's so much more than that. Other definitions focus on deployment times. DevOps is not solely about getting the product out there fast. Those definitions don't tend to focus on the fact that we need high or strong collaboration in order to be able to provide this value, to provide those high deployment times of a quality product. So just as a teaser before I get to the end, I'll say that at its core, DevOps focuses on promoting change through techniques, including communications to improve quality throughout. Now, for this research, I carried out a meta-study, and a meta-study is a study of a large number of studies. The idea being to look at the desire for a standard in DevOps. DevOps itself is not new, but do we really need a standard in it? So the meta study was to look at the desire for stability in defining what those principles and practices are, but also to look at things like the literature surveys that are out there, those studies that are provided by industry. What do they give us? Are we really moving forward on this at all? So we want to also look at the knowledge that is already in place. Is it really clear what we understand, and do we have a clear concept moving forward as to what are the key success factors for an implementation of DevOps? And we want to see this from an industry perspective. As an academic, there are certain things that I look for, but at the end of the day, we want to apply this in industry. So I've taken a large number of surveys. In fact, I've taken all of those major surveys that you're likely to have heard of. Some of them, the state of the developer ecosystem, the state of DevOps. These surveys are or have been out for quite a long time. Some of those surveys have been running for over 10 years. I've analyzed the surveys from 2011 right through to the present point of time. This gave me the opportunity to do a longitudinal study. Now, that longitudinal study has not previously been carried out. Now, what's important about it is that we're seeing from different organizations, different perspectives about what is required, what is considered best practice. Now, this study involves over 277,000 responses that I analyzed as part of this study. Well, I say 277. It could actually be a lot more than that if you believe the numbers of these reports. And I'm going to tell you that I don't believe the numbers in these reports. Now, that's a shocking statement. I'm about to present work, and I'm telling you that not all of that work adds up. I have a serious concern about how the numbers don't add up in some of these studies. There are some great studies in it, such as the DevSecOps community survey, and they release their raw data. Of course, it's anonymized, but they release it in order to show that they truly believe in what they're saying, and you can check it out yourself. Other well-known surveys, in fact, the most well-known survey, and I'm not labeling it out of the ones that are here, but it does not provide the numbers. And if you add up the numbers that they present year on year, the physical numbers don't add up to what they say they are. So there's definitely something funny going on. And we're not talking about approximate numbers. It's where they state this exact number. Year on year, they add them up. It does not add up. But let's get to the core findings. We want to look at the respondents of these surveys and see, are they truly representing the community out there? Many of these surveys are translated into different languages. They're not just in English. So we have 9 different languages that some of these surveys are translated into. That helps ensure that we get a broad reach of audience. Our respondents are coming from different countries. That's important because how we program in different countries changes. How we deal with industry, what laws we're expected to follow changes in different countries. So we have a large base from Europe, Asia, Russia, Africa. So we're getting a good reach across the world. Now, as I said, my particular interest is in the highly regulated industry. So I'm focusing here on finance, insurance, healthcare, pharmacy, and such like. although there are many more. Telecommunications, energy, and so on, they also fit under the same umbrella. Now, those respondents made up 33% of the overall respondents of these surveys in the meta study. Now, that means 1/3 of the people who filled in this survey were from these highly regulated industry. And why? Well, because they're getting the response back as to what is expected and what, more importantly, can be achieved when you apply DevOps. So it's there, the need is there. We have seen that there is a need to do these types of studies. Now, if we look at the roles that people are filling in, that has changed greatly from the beginning of the surveys to these later surveys. We're seeing more roles pop up along the terms of DevOps or SRE. But again, let's look at more broadly what roles are the people in who are filling in these surveys. You're seeing more management and consultants. Why? Because they want to see what gains can they get out of applying DevOps. Now, the surveys overall break down the idea of what is your best practice. If you're really good at DevOps, how do we classify you? So they classify them into 3 broad categories. That's high, medium, and low level DevOps companies. That is, you're applying DevOps to a good strength, a high strength, medium, and low. But the landscape has changed so quickly, they actually had to invent a new category, which they called elite. And in fact, you can see from my diagram, I've left a little bit bigger of a gap between the elite and high. I did that on purpose because I want to show that they had to put that big stretch in because the improvements that were being made from DevOps was actually quite large. So that gap is now increasing. How do we measure if you're a good company at DevOps? How do we know that you're applying best practices? There were 4 key measures or key performance indicators that were listed. The first being deployments. How often do you deploy? The second, the change lead time. How long does it take you to take a change from the need to make the change right through to deploying the new code at the end? Mean time to recovery when there's a failure or some reason for an outage. And then change failure rate. How often do changes occur? How often do these failures occur because of that change? Now, like I said, in 2019, just as one rough example, in 2019, when you deployed once per day, and that meant that, well, between once a day and once a week, that was a high performer. But now that change has taken place so that we have high performers appearing at once per week to once per month. And the elite are making those deployments multiple times per day. Now you have to ask yourself, are they truly deploying multiple times per day, or are they taking very small slices and deploying those small slices where somebody else who is measuring themselves, they're measuring based on large changes? Now, if these users are filling in the documentation, there is certainly a high.
I'm sorry for interrupting you, but 2 minutes more. Yeah.
That's okay. That's okay. Nearly there. Now we're coming to the point where we've got a highly regulated industry, and we know that disaster drives change. So we do need to have these standards in place. And disasters, such as in the HSE, where systems went down. Why? Well, systems went down because of an attack. This is true, but the attack was successful because there were legacy software in place. If we had good standardized DevOps processes, those types of attack would be less successful. I won't say it drives them all out, but it will certainly make those types of attack less successful. So those companies that are elite in their DevOps practices tend to apply more security, and that's not seen presently in a lot of younger companies. So let's look at some of the recommendations that I want to make today. I want to get you to focus on 6 key things. First, apply continuous improvement and risk management. Second, apply strong governance, which will help with this. Third, highlight the security practices, make them visible, and they will be done more often. Allow efficient communication so that we can communicate what's going on in each area and fix those problems. Use standards to promote consistency across what you're doing. And there is actually a standard out there, and that is the DevOps IEEE 2675 standard, currently being ratified as an ISO standard. And that will help guide you on what is best practice for DevOps. And that brings me to questions.
Thank you for the presentation. So I don't have any question on the chat, so it's over to you, Professor, for your questions. So, Professor, do you have any question that you wanted to share? It's really impressive presentation.
Thank you.
Thank you for it. Thank you for it. Yeah. I'm not sure. Maybe the doctor is not able to connect now, but for sure we will get back to you for any further inquiries. But for me, it was really impressive, and your effort is clear. So all the best in the rest of the project, and thank you again for presenting with us. Then, okay, here's moving forward. Yeah, moving forward to the next presentation. We will different area of technology, but still we will still under the same umbrella, where we are all changing our minds and changing our future with technology. We will talk about, or we hear about a low-cost smart monitoring device for demand-side response campaigns. It will be presented by Carrier on behalf of the co-authors. So Carrier, it's over to you, dear. You can share your slides. I will stop sharing from my side, and we are all with you. All the best with your presentation.
Yes, thanks for the introduction. I'm sharing my screen. Can you see the slides?
Yes, I can see the slides and we can hear you clearly. Go ahead and all the
Perfect. Thank you. So I'm Federico Carrere, I'm a PhD student. I'm collaborating with the Sapienza, the University of Rome, and with ASM, that is a multi-municipality of Terni city in the center of Italy, and it is the distribution system operator of electricities and also of other services. And this paper is entitled "A Low-Cost Smart Monitoring Device for Demand-Side Response Campaigns." In this brief presentation, I will introduce the theme of the demand-side response campaigns, in particular in distribution networks. I will present the smart monitoring device as it is composed, and also how it is deployed in Terni environment, in particular in the ASM headquarters in Terni city in the center of Italy. In the last part of the presentation, I will present the results and the conclusions. First of all, I want to underline that due to the environmental and sustainable needs worldwide, also in the energy sector, there is a great importance about the monitoring infrastructure, in particular due to the possibility to exploit the flexibility from the energy assets like production plants, like photovoltaic plants, eolic plants, and so on, to increase the penetration of renewable sources, and also to increase the energy efficiency and the environmental targets. In particular, the demand-side campaigns allows to exploit the flexibility of the assets, in particular, for example, to reduce the reverse power flow, that are the power flow that flows from the energy districts to the distribution grid. And in this case, there is a surplus of energy in the energy district that is not good for the distribution network of electricities. In particular, in this paper, I will propose a cheap and reliable device that is based on the Raspberry Pi. And this This component is very useful to implement these demand-side response campaigns, and so to achieve the environmental and technical requirements for the energy grid. In the figure, you can see the smart monitoring device. In particular, this device is composed by two Raspberry Pis, the Raspberry Pi 3, the Model B, and the Raspberry Pi 4. In particular, the Raspberry Pi 4 is the server, and the Raspberry Pi 3 consists of the client. In particular, this component, this device, is used in our case study for monitor the 4 variables in a secondary substation in the distribution grid. In particular, the secondary substation that provides the electricity to ASM headquarters. In particular, the temperature and the humidity in the secondary substation are gathered. They are very important from a secure point of view, and also the voltage and the current, in particular the root mean square values, are collected in order to exploit the demand-side response campaigns and to achieve an energy efficiency in the district. This is a brief recap of the sensors that are present in the component, the device, in particular a temperature and humidity sensors that you can see in the figure. This is a SenseHet sensor that is implemented in the device, and there are also a voltage sensor and a current sensor. The current sensor is a Rogowski coil, and this sensor is the less cheap, is more expensive than the other parts of the device. And in future investigations, the other authors and I will proceed to study another type of current sensor to make the device also cheaper. Naturally, an analog to digital converter is also present in the device. This is a recap of the main features of the Raspberry Pi 3 and 4. These are very cheap devices. You can see the most important characteristics about the processors, the memories, and also the connections. In particular, I want to discuss the infrastructure, the telecommunication infrastructure of the device with the Energy District Office. In particular, as you can see in the figure, the Raspberry Pi 3 is the component that collects the measurements. You can see the SenseHet, that is the temperature and humidity sensor, and the voltage and current measurements that are gathered by the Raspberry Pi 3. The Raspberry Pi 3 connects to the Raspberry Pi 4 through a wireless communication, and this is the Raspberry Pi 4 is the server of this infrastructure. Through an APN, a mobile APN, and passing through a firewall, the data are collected in the office of the energy districts, and these data are used to make possible the demand response campaigns. In these slides, you can see the device in the rectangular, in particular in the figure, that was installed in the secondary substation of the ASM headquarters. I want to present the ASM headquarters, in particular identifying the most important characteristics. The ASM headquarters is characterized by 4,000 square meters of office building. It presents also a photovoltaic plant of 60 kilowatt. and present an annual consumption of about 650 megawatt hours. In particular, the headquarter presents technical offices, a computer center, and also an operation control center and a warehouse. You can see the electrical single line diagram in the figure on the left. This is an example of the results that are and the main data that are collected by the device during some measurements campaigns. In particular, I'm reporting the log file that is created by Raspberry Pi 3 and that is sent to the Raspberry Pi 4 on the left. In particular, you can see the date, the time, and the voltage and the current. For example, 239 volts and 40 ampere for the first line of this data set. In particular, the data are collected every 15 seconds, and in the diagram you can see that the voltage is ranging between 2042 and 2031, and the current between 30 and 150 amperes. You can see that there are many oscillations and the curves are very jagged, but this is not due to the monitoring device, but to the different types of loads and production plants that creates a variegate profile of the headquarter. In conclusion, I want to underline that the most important aspect of this monitoring device is that the components are very cheap and they are useful to put this type of components in the entire distribution grid, in each secondary substations of the distribution grid. You can think about that the number of secondary substations in the distribution grid of Terni City are about 600. So the economic aspect is very important when we want to have a smart monitoring in a such capillary way. Moreover, in future investigations, we will propose also a machine learning technique for the analysis of the data and to avoid the possibility to send and transfer data that are not useful for the demand-side response campaigns. And moreover, the Rogowski coil, the current sensor, will be replaced by a cheaper sensor that could make this type of device also more cheap. So thanks for your attention. I don't know if there are some questions or remarks.
Yeah, thank you for. Yeah, thank you for the presentation. It's really great and your effort is clear. So I have a question from the professor regarding electric distribution network evolve a very high voltage. So how did you monitor such high voltage using Raspberry Pi?
Okay, the Raspberry Pi and the two Raspberry Pis and also in general the smart monitoring device are connected into the secondary substation at the low voltage. So these connections are related to voltage, a nominal voltage, rated voltage of about 230 volts. So this is a type of smart monitoring device that is thought to monitor the single customers, the single users, or the single energy districts. So, for example, in one secondary substation, it could be deployed more than more than one devices in order to collect data from various type of customer. In this way, we can check and we can also create demand side campaigns also with the low voltage customer, with the prosumers and the users that also produce energy or more than only have a consumption of energy. I don't know if I gave a contribution to Professor for this question.
Thank you, Federico. Yes, you answered my question. Thank you very much.
Thanks.
Thank you, Professor, and thank you for the great presentation again from me and from everyone in the room. So thank you again, and now we will move forward to the next presentation where we will tackle another important issue to all of us, which is related to improving mean average precision of camera and reader fusion network for object on behalf of the co-authors. All the best in your presentation. I will stop sharing and you can share your screen. We are all listening.
Thank you.
Yeah, thank you. We can see the screen and your voice is clear. All the best again.
Okay, perfect. Thank you. Well, hello, everybody. My name is Sheetal Prasanna, and I am a graduate student at the Purdue School of Engineering and Technology at IUPUI. I am working on my master's thesis with Dr. Mohammed El-Sharkawi. Today, I will be presenting to you one of my studies that is about radar augmentation in a camera and radar fusion network for object detection. Okay, so here is a brief summary of what I will be going over today. We'll start with an introduction and the motivation behind this study. Then I will talk to you about the baseline architecture followed by my proposed architecture. And then I will discuss my implementation, results, and we'll end with some concluding remarks. As we all know, machine learning is growing in popularity for various different applications. This study uses machine learning in the field of automotive applications for the purpose of object detection. Being able to accurately detect and classify objects on the road is one of the first steps in the development of self-driving cars. Another novel concept that's used in this study is the idea of sensor fusion, where more than one sensor is used in order to balance the strengths and weaknesses of each one. The two sensors that are used in the study are camera and radar. As we all know, camera data is great for visualization, and it's also very easy to annotate and classify objects. However, camera data becomes unreliable in bad weather conditions like rain or snow, where the camera can very easily be obstructed. Camera is also unreliable during the night. Radar data, on the other hand, is very difficult to visualize because it's hard to tell what a set of radar data points is pointing at. However, radar data is much more robust and reliable than camera in all weather conditions. And so this study is based on the idea of projecting the radar data points onto the image in order to make the final radar augmented image much more reliable. The motivation behind this study comes from the scarcity in radar data that's available in literature today. Moreover, there's also a lack of augmentation studies that focuses on augmenting radar data. Following the general heuristic of machine learning, which states that more data leads to better accuracy, this leads us to the most popular technique of getting more data, which is augmentation. There are various different benefits from data augmentation, including improving accuracy, which in turn gives us a higher confidence in our predictions. It also shows signs of reducing overfitting, which is a common issue where the model performs really well with the training data set, but then performs poorly with the validation data set. Moreover, data augmentation allows us to get more data without the need of extra memory or space. It is also cost and time effective because it prevents us from going out, setting up sensors and collecting data ourselves. The baseline architecture, as I mentioned before, is based on the concept of fusing camera and radar sensors. The dataset is from NewScenes, which is one of the biggest automotive datasets that's available open source. The dataset includes radar, LiDAR, as well as camera data, and also comes with a development kit for researchers to easily access and manipulate the different sensor data streams. Here is a brief flow of how the network works. You can see here that the image blocks are fed through multiple convolutional layers, while the radar projections are fed through multiple max pooling layers. And before each layer, these two are concatenated. This leads me to my next image, which shows the 3 steps of a RetinaNet architecture. So we have the feature extraction, which is followed by the feature pyramid network that's built. And then that is followed by the detection head, which computes the classification and regression losses in order to update the weights. The network is set up so that we can run it with various different configurations, including image augmentation, normalization, various different filters, and so on. The performance is measured using the standard mean average precision score, and the baseline accuracy score was found to be around 36.7%. The proposed architecture is inspired by image augmentation techniques due to the nature of the dataset. I will be discussing the nature of the dataset in the next slide. Image augmentation methods like scaling, shifting, flipping on either axes, rotation, and a combination of these methods were implemented. For the new scenes dataset, the X coordinate corresponds to the front of the vehicle, while the Y coordinate is the left. The Z coordinate is the height, and the original study found that fixing the height to 3 meters gave us the best accuracy and the best performance. And this is the reason the Z coordinate was not augmented. On the right, we can see the data that's being read from the new scenes using the development kit. We have the X, Y, and Z coordinates followed by a lot of metadata. For example, we have RCS, which is the radar cross-section, we have velocity information, and also distance. As the radar coordinates, X and Y are the ones that are being projected onto the image pixels, only X and Y were augmented. And because these coordinates are being mapped to the image, we are able to use image augmentation techniques. And so therefore radar data was augmented using the mathematical operations that you see on this slide, and the new data was simply appended to the end of the existing array. This gave the network the impression that the dataset itself was being expanded. Online augmentation was implemented, meaning that all of the new data that was generated exists only during training, which helps save space. Also, the mathematical operations were performed on each of the data points, and this took only linear time. Scaling was performed by multiplying the data by a randomized value. Shifting was done by adding or subtracting a value. Flipping on either axis was done on a probabilistic method where the flip was done approximately half the amount of time. And rotation was done using the standard Cartesian coordinate formula that you see in this image. Randomization was used for all of these in order to eliminate any possible bias. And the randomization values were taken from the image augmentation implementation that was in the existing network. And here we can see the results of my experiments. On the top right image, we see the image before radar augmentation, and on the bottom, we have the result with radar augmentation. We can see clearly that there are a lot more radar data points that are being associated with the image pixels, giving the network more points to work with. As mentioned before, the baseline accuracy was around 36.7%. The image augmentation that was implemented in the original study actually performed worse than the baseline with only a 27% accuracy. However, we can see that all of the radar data augmentation methods improved the score, with scaling and flipping over the y-axis giving us the best performance. Flipping over the y was the best improvement seen in the study, which gave us a 45% map score, which was around a 21% increase in performance. It was also found that each of the data augmentation methods worked better independently than together. Another observation that was made was with regard to overfitting. You can see in the first row of this table that there is a pretty big gap between the training score and then the validation set score. However, as we started to apply data augmentation, we saw that gap slowly start to decrease, which is a positive sign for the reduction of overfitting. And this leads to our conclusion, where from these results, we were able to almost double the amount of radar data points that were fused with the image, thereby giving the network the impression that we expanded the data set itself. The heuristic of machine learning states that having more data leads to better accuracy. And we saw evidence for this where we saw a 21% increase in the mean average precision score. We also saw signs that augmentation was helping to reduce overfitting with the reduction in the gap between the training and the validation scores. Overall, radar augmentation was almost 50% more effective than image augmentation to improve the performance of the network. From these results, we can conclude that radar augmentation is a good technique to help expand a given data set and improve any object detection network. Thank you very much for your time and the opportunity. Are there any questions?
Thank you for the great presentation. We have one question. I will read it to you if possible. The professor is asking you, can you apply your technique of object detection in real time, as there are lots of clusters from the radar return, and did you identify a given object? He supposed that the training of AI must have been time consuming. You can look into the chat for the question if it's
yes.
We'll forward it to you. Because it's time consuming, he assumes that it might be not applicable directly. Okay, I will share it with everyone.
I can see the question now.
Yeah.
There is opportunity within the network to run it in real time. There is an inference option. So the thing with the radar data is that we're receiving processed data from new scenes, and that's one of the best parts about the new scenes data set. And so that helps a lot to get rid of the clutter from the radar return. And like I said, they also have filters implemented in the original study that can be used to further get rid of any unwanted radar data points that come with the radar sensor and the way they work. The training is actually not that time consuming. So with the mini data set, it takes about just less than an hour to train. And I think there is scope to compress the network and make it run even faster. But yeah, the real time has been left for future work because it is a little bit more complex. I hope that answers your question.
Yes, thank you for the answer. Okay, thank you, dear. All the best in the rest of the project, and it's really informative. Now we will go ahead with the next presentation, which will take us to another area of the research, finite element of biomechanical model of a human microcardium from a cardiac MRI images, to be presented by Ms. Rania Awadi on behalf of the co-authors. Yeah, so it's over to you. Hi, you can share your screen. I will stop sharing.
Screen. You can see my screen? You can see now?
Yes, I can see it, and we can hear you clearly. All the best. Go ahead, please.
Okay, thank you. Good afternoon. Thank you to each and every member of the Congress for acceptance of my paper. Allow me to introduce my work entitled Finite Element of Biomechanical Model of the Human Myocardium from Cardiac MRI Images. The plan for this presentation is the following. First, we will start with the introduction, and the problem. Then we will explain the numerical simulation. The second compound of the presentation will be devoted to presenting the results and the discussion of the contribution, to end with the conclusion. Myocardium infarction is a heart disease that occurs when the heart does not obtain enough blood and oxygen. Post-myocardium infarction alters the mechanical parameters of the heart. Biomechanical models of the myocardium provide more details of the heart behavior and several biomechanical parameters. Cardiac magnetic resonance imaging provides some information that can be used to model biomechanical models. The radiologists are not able to detect these mechanical changes. In this context, computational mechanical model of left ventricle is a useful tool in diagnosis of and treatments of for heart failure. So we use the cardiac magnetic resonance to provide access to several of the complementary information needed to blood cardiac model, for example, tissue characteristics and motion. Many authors has been developed to compute mechanical models of the myocardium. In this work, we present a biomechanical human left ventricle models that are derived from clinical imaging data. The biomechanical models can be composed of 3 steps: left segmentation, then the left reconstruction 3D, and the 3D cardiac modeling. This is the diagram of the proposed method. Let's start with the first step, the segmentation. Short axis, the 2-chamber and 4-chamber long axis images were chosen for left ventricle segmentation. We use a circular cardiovascular imaging software. We used a circular cardiovascular imaging software. This is the result of the segmentation. The green contour is the left ventricle epicardium, and the red contour is the left ventricle endocardium. Then we import the segmentation results into a commercial software LS proposed to assemble left ventricle epicardium and the endocardium. Ascent points of the endocardium and epicardium in 3-dimensional area are then immediately created from these contours. We used Hyperwork software to generate the left ventricle walls reconstruction. This is the result of the assembly. And this is the result of the 3D reconstruction, left ventricle reconstruction. The last steps is one of principal function of left ventricle segmentation is 3D cardiac modeling. According to the SolidWorks results, we used Abacus software to create 3D volume mesh. The hexagonal mesh for each subject composed of 3576 C3D 8R elements. The ancestral geometry has been chosen as reference. This is the result of 3D mesh model. Then, to evaluate our work, a clinical metrics of left ventricle simulated from the mechanical models and diastole and systole volumes and diastole wall thickness. The tables show the normal left ventricle and diastole and left ventricle and systole volumes according to gender. For the male, the left ventricle and diastole volume, it's between 60 to 110 ml, and for the left ventricle and systole volume is between 20 to 66 ml. For the female, it's between left ventricle and diastole, it's between 58 and 103 ml. For the left ventricle and systole, for the female is between 26 and is between 26 ml. Normal sex and age specific reference range for left ventricle mid-diastolic wall thickness. The upper limit of wall thickness for any segment was between 30.6 mm for men and 11.2 mm for women. As an additional method evaluation, the metrics obtained from the left ventricle simulated were compared to the ones measured to the normal values found in literature. The results and the discussion. This table shows the results of the left ventricle metrics on the 20 volunteers. For the healthy subject, the normal values range of end-systolic and end-diastolic volumes were determined to be between 82 82 ml and 58 110 ml respectively for the 2 gender. We obtained with personalized simulated subject 8 and systolic and end-diastolic volumes respectively between 29 ml, and 74 ml. Those are in 4% of the normal values. For the left ventricle wall thickness, the main normal value for the subject 8 from base to the apex was 10.3 mine plus 1 mm for base, 10.2 mine plus 0.9 mm for mid cavity, and 7.3 mine plus 1 mm for apex. Using our personalized simulation, we obtained left ventricle wall thickness of 8.23 mm for the same patient. The conclusion, MRI has become the most sensitive clinical that can be used to model biomechanical model. Biomechanical models capable of predicting subject-specific parameters will be a useful tool to assess the condition of an ischemic patient. In this work, we modeled a biomechanical human left ventricle in healthy subjects. Left ventricle and systolic and diastolic volumes and wall thickness from 20 subjects were estimated based on cardiac magnetic resonance images and biomechanical modeling. The modeling method was largely evaluated by comparing the simulated value to the normal values. Some perspectives calculate biomechanical parameters, example the strain and the contractility, developing a left ventricle model for patients with ischemic myocardium and estimated their biomechanical parameters. Thank you for your attention.
Thank you for the presentation and for the great effort. It's really helpful and will change the way that we are dealing with heart diseases. So all the rest and the rest of the project, we have a question which is, were you able to dynamically change the structure of your model using the Alter software to see the stress of the model structure? I will copy it back on the chat to make sure that everyone also can read it. Yeah.
Were you able to dynamically change the structure using the Alter software to see the stress structure? Yes, I'm using Abacus software to simulate the mechanical parameters. I simulated the volumes, and now I'm working about to simulate strain, contractility, the mechanical parameters. Yes, I hope that.
Yes, thank you. It answers, yes. And thank you for the effort. You might need to just elaborate more when you are writing the full paper on this idea to make sure that it's clearly explained. Now we will move forward to the next presentation on another important topic as well, which is completing another side of the technology implications. Would be provided by Mr. Nito on behalf of the co-authors under the title and ontological model for fire evacuation route recommendation in buildings. So it's over to you, sir, and we are all listening. All the best in your presentation. Thank you. You can share your screen.
Thank you.
Yeah, I stopped the sharing.
I think you are seeing my presentation.
Yeah, I can see the presentation and your voice is clear.
Okay, I will start. Good afternoon to everyone, and thank you for attending my presentation regards to an ontological model for fire evacuation route recommendation in buildings. My name is Joaquim Neto, and I'm a PhD student in Portugal at the Universidade Aberta in Portugal. The outline of my presentation, I will start with the problem statement and the motivation for this research work, the related work, ontologies and development methodologies, as well as the ontology development life cycle. The concrete ontology that was built during my research work, and the conclusion and future work. Concerning problem statement and motivation, it falls, this research work falls within the scope of our ongoing PhD thesis, under which we are studying how a multi-agent recommender system can guide the occupants of a building to a safe place in real time in a fire emergency situation. It is a thorough knowledge is necessary to understand the problem of building evacuation under fire emergency, and because of that we developed another paper, another ontology, an ontology for fire building evacuation that I have presented last year, and that allows us to better understand this domain. However, it is essential to deep that knowledge in order to understand how to guide occupants in real time through by recommending evacuation routes, and because of that we extend the ontology of 2021 to understand that domain of real-time recommendation of evacuation routes. The related work in literature, we identify different ontological approaches in treating and dealing with fire emergency in buildings, focusing on the response of the different actors involved in emergencies, the fire control knowledge, the modeling knowledge about fire safety, including the building evacuation problem. However, we have not found a concrete the case. One moment, please. We have not identified research works that deal directly with the recommendation of evacuation routes in real time, which is the domain of our research work. Ontologies can be defined by Grover as an explicit specification of a conceptualization, when objects, concepts, and other entities and relationships among them are used to represent knowledge within a domain. And in computing and information science, the term ontology refers to an artifact designed to model the knowledge about a domain. Or another definition on the ontology consists of terms representing hierarchically organized concepts at some specifications of their meaning. The ontologies also contribute to understanding a domain and help the interoperability between people and between heterogeneous systems. Concerning ontology development, I found four main representative methodologies: TOV, Enterprise, Methodology, Ontology Development 101. In our work, we followed methodology. Concerning the ontology development life cycle, all of the methodologies considers 5 stages for the life cycle developing of an ontology. The first one concerning the specification stage to identify the purpose and scope of the ontology. The conceptualization stage where we describe the ontology to be built through a conceptual model. The formalization where we transform that conceptual description into a formal model. The implementation stage where we implement the formalized ontology in a knowledge representation language, and the maintenance stage where we update and correct the implemented ontology. And of course, during all that cycle that may take months, three activities must be considered during all that cycle. The knowledge, the acquisition of new knowledge, the documentation of the ontology, and of course the evaluation. For the specification stage, you need to answer to these main four questions. What is the domain to be covered? Why you build the ontology? What are the intended uses, and what kind of answers should be the ontology give? You obtain all that information from the Portuguese, in this case, from the Portuguese legislation, from the feedback of experts in the field, and also with a set of competency questions that I put it there. It's about 10 competency questions. I will focus two of them. This one, that what type of emergency signals exists in the building, and how could the emergency signals help occupants through the evacuation process? Or, for example, how can the Internet of Things contribute to creating a solution capable of guiding occupants to a safe location in an emergency situation? These competency questions allows us to define, to specify the ontology and set up their requirements concerning four main blocks: defining the ontology domain, the ontology goal, the ontology contribution, in this case to provide the ability to strengthen and consolidate knowledge about building evacuation under fire emergencies, and provide knowledge model to support the development of evacuation solutions and systems in real time for guiding occupants of a building in a fire emergency, and a set of answers that we, by interrogating the ontology, must want to be answered. At the conceptualization stage, you build a conceptual map on top of the previous one developed for the ontology for fire building evacuation, and build all the ontology of the terms around that situation. I focus here four main terms: the Internet of Things, and all the IoT devices, and the recommender system that will recommend evacuation routes to the occupants, and a graph that represents the building. At the formalization and implementation stages, we use the Protégé framework, and we had 14 new classes that are highlighted in the images, and 20 new object properties. This is an example of construct the classes in Protégé. For this case is route recommenders for route recommender systems. The same for object properties that relate instances of two classes, and for data type properties that relate an individual of a class to a primitive value. In this case, we have here is an IoT device to specify that some device, a sensor or an automatic detection system, can be considered an IoT device and provide data for the recommender system. This is the graphical representation of the ontology, where you can easily identify a set of classes that represent the building, another set that is related with the recommender system, and the context that is represented by a graph, and all the context generated by the the sensors or by the risks, by what is happening in the building, all of that connected through Internet of Things. The evaluation is an iterative process that I already told that occurs during all the development process. You used some tools that exist on the web, or the ontology improvement tool for syntactic validation, to check ontology consistency, to verify if the semantic web data is correctly published and follows best practice, and also use a tool with code for help in the ontology documentation. The tests carried out with the tools referred to above were completed successfully and are available for consulting on the ontology query. Another way of evaluating the ontology is an evaluation against the referential. In that case, the referential is embodied by the specification requirements and the competency questions, which must be answered by the ontology. It is an evaluation dimension that assesses whether classes, properties, and axioms can be answered, the questions and requirements. You can use Sparkle for interrogate the ontology. In this case, you have an answer to the question how to guide the occupants to exit the building. You can see that from the IoT input device, a sensor that sends raw data to IoT input device model inside the recommender system, and so on until the data is presented in an IoT output device for occupants. The occupants follow the signaling. In conclusion, the ontology contributes for the understanding of the domain of real-time recommendation of safe evacuation routes to the occupants of a building under a fire emergency, with a knowledge model capable of supporting the future development of more suitable building evacuation solutions and systems. Concerning future work, you are deepening the ontology through use cases, and you also used the ontology to support the development of the multi-agent recommender systems that we are developing under our PhD thesis. And that's all. Thank you for attending.
Okay, thank you for the great presentation and the great idea. Actually, I have some questions, not only one. The first one is, have you tested your model for its effectiveness? How does it vary for different sizes of buildings? This is the first question, and the second, I will post it to everyone, and the second one is on chat. I will go through it also after answering the first question.
Could you repeat the first?
Your model? Okay, have you tested your model for its effectiveness? Have you tested your Have you tested your model for its effectiveness? How does it vary for different size of buildings?
If I understand, the tests we have done is concerning the consistency and the ability to the model answer to the questions by interrogating the ontology with a language like Sparkle, for example. You develop that model according to the Portuguese legislation and to feedback of experts, but I think it is maybe deepen the model with other contributions from other countries. I don't know if that is the question, okay? But concerning the evaluation is concerning the consistency and how the ontology is able to answer to the questions that we formulate in the specification phase. I don't know if I answered what you are asking for, but
okay, yeah, thank you, it was answered. So the second question, you can also read it from the chat if my voice is not clear, which is the route recommendation will depend on mobility of the pedestrian. This is depend on local national guidance. Have you concerned this? She means that the definition of mobility is dependent on local and national guidance.
yes. It's that is one of the problems that we are dealing with in our PhD phases, okay? And one of the kind of research in the area is to try to understand and to comprehend the behavior of the pedestrians inside the wheel, okay? The problem is that due to cultural differences from countries to countries, the behavior may be different. In our work, you are talking about a paradigm change in a way that instead of waiting for how the pedestrians behave, the idea is build a system that is able to guide them, okay? A system that was not worried about the specific behavior of a pedestrian, okay? But a system that in some way puts the building to guide in a whole the pedestrians during an emergency situation.
Yes, thank you.
And considering the sizes of buildings, it is independent, because in the first in the ontology that we presented last year, you have classes where you can put different floors of a building and so on. Even the old ontology is independent of the size of the building, independent of the number of floors of the building. What we are dealing in the ontology is to specify a knowledge model that be capable of and contribute to the development of solutions for helping the occupants of a building to exit safe from a building. Okay.
Yeah. Thank you for the clarification and for the great efforts. All the best on the rest of your PhD. So now we will move forward to the last presentation, which is from the previous session, but due to technical reason, we were not able to present. So it's over to you, Mr. Derayo. You can present your slides. I stopped sharing from my side.
Hello.
Yeah. Hi, Mr. Derayo. We can hear you clearly. Could you please just share your screen?
Yes.
Okay, we can see the slides and we can hear you. Go ahead, please. All the best.
Okay, in this case,
I speak about the design of a cascade single multi-level inverter for photovoltaic application. Today, energy generated by unusual energy source is predicted to satisfy 50% of total energy needs by 2050. Today, photovoltaic systems, including inverters, are connected to the grid to supply electrical power to power distribution networks, and the smaller system employ some maximum power point tracking technique to make the best use of the solar energy. The multi-level inverters MLI reduce a given to voltage some standalone DC source, which can be solar cells, batteries, or full cells. These inverters improve power quality, generate sinusoidal currents or voltage, reduce common modal voltage, decrease the number of semiconductors, and do the low dB, decrease the feedback, the interruption, the communication lines. In the figure, we have three signals, the fundamental, the harmonic, and the sum, the fundamental plus harmonic. The fundamental criteria for the choice of any modulation method are sinusoidal output with a low THD and low losses. One of the most commonly used modulation strategies today is the pulse width modulation, PWM. In the literature, we find some modulation techniques for multi-level. In this case, vector space and voltage level. In this figure, we can see the more common technical modulation there are used. In system discretion, each power cell contains 4 switch and isolate source. The number of levels in the CHMLE can be incremented adding more than 1 cells. In this search, we use a symmetric source because the system. In the equation 2, we calculate the number of levels that the CHMLI, the maximum amplitude the CHMLI must be is equal S to E, the number levels for the symmetrical source. The PSPWM modulation we use it con out-of phase multi-carriers, and the equation 4 we calculate the phase, the angle theta. To apply the PSPWM technique, it's necessary to have 2 carriers for each full bridge connected in cascade. Therefore, the number of carriers obtained is using equation 5. The relationship between the ripple frequency and the switching frequency is given by equation 6. The modeling inverting use the equation 7 and 8, and the relationship is the filter in the equation 9. The natural frequency system should log in equation 10. It can be determined at work a decade earlier than the switching frequency. In the output filter design, we have the next consideration. La frequency equals 2p frequency code of the calculation, the resistance or load. We use the equation 14. And the input filter design, the Fourier analysis performance on the input current of H bridge result in a component at 120 Hertz. Therefore, the input filter design is performance at this frequency. We have applied the Kirchhoff laws for the current in the capacitor. To control the ripple voltage, I use the equation 16. Result and discussions, PSPWM modulation, de CHML implementado fue in Simulink. The modulation, we have the carriers, and the CMLI, we have the three levels. In the figure presents a carrier waveforms at 20 kilohertz and the same waves to generate the modulation wave at 60 hertz and the figure B. You can see the voltage and current at the input of the cascade inverter. In this figure, we can see the results obtained with the technique modulation employed. In the next figure, you can see the voltage at the output H bridge and the system connection to the grid. For the Fourier analysis, a frequency 10 times higher than the switching frequency 100 kilohertz was used in the cycles where tank analysis can be seen in the figure B. THD analysis of the CHMLE output signal is performed to validate the developed design. In this figure, we can see the results, the CHMLE. The THD value in CHMLE design is 2.330%, which warrants the quality of the signal obtained. This value is below the THD obtained in similar works and similar modulation techniques. In Ecuador, THD maximum is 50% to connect the system on the grid. For future work, the implementation of CHMLI with solar panels and the following developed boards, Arduino, Raspberry, and DSP will be performed to contrast the result obtained so far and compare the results with similar implementations. This with the idea of making local systems to popularize their use in Ecuador. Conclusions, the PSPWM modulation technique shifts the frequency of the output voltage ripple to higher frequencies, reducing the size of the output filter and obtain good performance in the reproduction of distorted signals. A 7-level CHMLI was designed and the Butterworth approximation was used to design the output filter, obtain a THD value of 2.30%. Different simulation tests were performed to observe the behavior of the multi-level inverter under the use of a resistive load, concluding that the multi-level inverter has an excellent performance. Based on the CHMLI design perform and simulate, the CHMLI will be implemented with solar panels and the Arduino, Raspberry, and DSP development boards to contrast the actual performance of the CHMLI. Thank you for your attention.
Yes, thank you for the presentation and all the best for the rest stages of your research. You don't have any questions, so we can go to the next stage, which will conclude the whole session. Thank you again for everyone for your time and for the great presentations. We are coming to the last part of the session. So yeah, could you please just make sure that all mics are muted? I'm sorry because I'm hearing myself back. So yes, we are okay. I sincerely thank you, our authors, for the excellent presentations and contribution in the session. All presentations are great and add value. So thank you again for being part of this international conference. I hope this session was informative enough for everyone. All of those who presenting will get the digital certificate through the email within couple of business days. Further, all the papers have been already forwarded to Springer, so no worries, but please keep an eye on your email. You will receive, with ICICT team, you will receive emails. It's supposed to be published within 5 to 6 months. I also thank the chair of our session, Dr. Bal, for the great contribution and for the questions. Thank you again on behalf of myself and the team of ICICT 2022 and Global Knowledge Research Foundation. So your time and effort is highly appreciated. Dear all, even that we are on the online or virtual mode, but we still have a good chance to have picture and document this valuable moment. So could you please just turn on the cameras if possible, and we can take a screenshot as a memory to every one of us where we can keep it in our records. So thank you again. I will take it from my side and the main host will take it as well. So thank you. I'll count 3, 2, 1. Smile, smile, smile. 3, 2, 1. Okay. Thank you all, and all the best in your academic life. You did a great job, and we hope to see you next year in the next conference. All the best.
Thank you.
See you. Bye bye.
Thank you.
Thank you. Bye-bye.
Thank you.
Bye.
Thank you.
Thanks.
Thank you.
Thanks. Bye-bye.